All right, thank you. Good afternoon, everyone. Thanks for joining today's GSSA Mentee presentation session. My name is Musa Mhlanga. I'll be presenting on the Sea Point contact and its historical significance. So the outcrop was the primary focus of my MSc thesis, and I'm happy to share information related to its historical and geological significance. So before highlighting the historical significance of the site, I'll first detail the geological setting and the primary geological features of the outcrop. The outcrop is located in the Western Cape province of South Africa in the city of Cape Town. It outcrops in the suburb of Sea Point and is approximately 5 kilometers away from Cape Town CBD and 12 kilometers away from one of Cape Town's other famous geological sites in the form of the Table Mountain. The outcrop is exposed over an area of 4,800 square meters and is relatively flat lying and offers a very well exposed view of an intrusive contact between the metamorphosed sedimentary rocks of the Neoproterozoic Malmesbury group and the granites of the Neoproterozoic to Cambrian Cape Granite Suite. The intrusion occurred approximately 540 million years ago and locally metamorphosed the Malmesbury group country rock to lower amphibolite facies. So the Sea Point contact is in the Saldanha Belt, which is a low-grade volcano-sedimentary succession situated along the southern and southwestern portions of the Western Cape and the Kalahari Craton. As can be seen from Figure A, it forms part of the Neoproterozoic, Pan-African, and Brasiliano tectonic belts, which record the oblique closure of the Adamastor Ocean, related to the construction of southwestern Gondwana around 550 to 500 million years ago. So the Saldanha Belt is subdivided into two branches, namely an east-west trending branch and a northwest-southeast western branch. Oh, sorry, east-west trending southern branch and a northwest-southeast trending western branch, as you can see in Figure B. So the western branch or the western Saldanha Belt, where the Sea Point contact is located, is the main exposure of the Saldanha Belt. So there have been many proposed lithostratigraphic subdivisions of the western Saldanha Belt throughout the years. So for this presentation, the subdivision which was proposed by Kistis and Belcher in 2018 is used because it provides the latest account of the subdivision. So Kistis and Belcher proposed that the Western Saldanha Belt comprises of two domains with distinct structural and strain histories. And they are the Lower Swartland Complex domain and the Malmesbury Group upper domain. So the lower domain is structurally more complex and lithologically more variable, whereas the upper domain is structurally simpler and covers a larger area. So these two domains are separated by an inferred unconformity. The metasedimentary rocks exposed at the Sea Point contact belong to the Tygerberg formation of the Malmesbury group. In general, the Malmesbury group is predominantly clastic sedimentary succession and is comprised of alternating metasedimentary layers of fine greywacke, mudstone, sandstone, siltstones, limestones, conglomerates, and it also has minor volcanic rocks, and was deposited around 560 million years ago. The granites of the Cape Granite Suite are intrusive into the Malmesbury group. So the Cape Granite Suite is primarily composed of S-type granites, which have intrusion ages varying between 550 and 535 million years, as well as I-type granites, which are younger, with intrusion ages between 540 and 520 million years. These were all formed during the Saldanha orogeny. These two suites are separated by the regional Colenso fault, which is highlighted here in Figure A. So the seen to lake tectonic S-type granites, they dominate the southwestern section of the Western Saldanha belt and that divided into 4 plutons, namely the Darling, Saldanha, Stellenbosch, and the Peninsula plutons. So both the Malmesbury group and the Cape Granite suite are unconformably overlain by the younger early Paleozoic Cape supergroup, which make up most of the geology underlying the Western Cape. So as previously mentioned, the main Cape Granite suite and Malmesbury contact zone is located at the sea point. It's at sea point and is marked by the intrusion of the Peninsula Pluton into the metasedimentary rocks of the Tigerberg Formation. So the Peninsula Pluton is largely undeformed and is the southernmost body of the S-type granites, stretching all the way from Cape Town to Cape Point. So as can be seen on the geological map on the left, the sea point contact shows a transition from Malmesbury group rocks in the north through a complex zone comprised of S-type granites of variable texture and grain sizes and metasedimentary rocks in the main intrusive contact zone before reaching the main Pluton area to the south, which is composed predominantly of the voluminous S-type perforated granite. So along the extents of the outcrop, there are also fine-grained varieties of the S-type granites, which are typically referred to as the microgranite due to the very fine-grained textures. So this is an overview image of the contact on the right. So the outcrop exposes a variety of S-type granites at a more localized scale compared to the rest of the Peninsula Pluton. The main contact zone not only provides evidence of the intimate association between the granites and the country rock, resulting in a hybrid rock of mixed character, but it also shows the concordant nature of the granite intrusion into the country rock, where the granites intruded subparallel to the lithological boundaries of the country rock, such as the bedding and foliations. This gives it its lead palette appearance, which resembles a banded or layered rock. So regionally, the rocks of the Malmesbury group have been metamorphosed to lower green schist facies during the Saldanian orogeny, whereas near the contact, they have been thermally metamorphosed to lower amphibolite facies conditions, with the primary minerals associated with the contact thermal metamorphism being biotite and cordierite. Furthermore, during the Saldanian orogeny, the rocks of the Malmesbury groups were folded into northwest-southeast to north-northwest-southeast orientated upright southwest virgin folds. These associated this folds associated with these folds is a vertical to subvertical foliation called S1, which is well defined by biotite at the contact. Oh, sorry, I wasn't. Okay, so figure A here shows the typical appearance of the country rock at the contact. So these were initially metamudstones and are now outcrop as a dark gray to black succession that is fine-grained and is weakly to highly foliated. So petrographically, the country rock has a granoblastic texture and comprises, in order of abundance, quartz, biotite, cordierite, orthoclase, and plagioclase. So the cordierite grains can be seen in figure B here, but more, this is a zoomed in portion of those cordierite grains. As you can see, they're typically rounded, equidimensional, but in thin section, they're very altered to muscovite in a process called pinetization. Okay, so while the use of the term hornfels will be more appropriate for thermally metamorphosed mudstones or siltstones, such as what we see at the sea point, the presence of a well-developed foliation, as can be seen in this thin section photograph, does not support the use of that term. So the term contact schist or spotted contact schists are more appropriate for the Malmesbury group at the contact, despite their fine-grained nature and not having the typical appearance of a schist, which is a term that is commonly associated with lower to mid amphibolite versus regional metamorphic metapelitic rocks. Okay, so now we move on to the Peninsular Pluton at the sea point contact. Various granite types or phases of the Peninsular Pluton occur at the contact. This include the main coarse grain porphyritic granite, a fine grain granite or microgranite, as well as hybrid granites. So the term hybrid granite is used to identify the different granite types and the variety of grain sizes and textures they display in the main contact zone because of the close association with the country rock, resulting in a rock of mixed character. So it contains like features of both both rock types. So the various hybrid granites that outcrop in the main contact zone are as follows. You have fine grain granites and the subvarieties in the form of the fine grain porphyritic and non-porphyritic. And then you have variably weathered, medium, and coarse grain granites. So all of these granites have a similar mineralogical composition to the main coarse grain granite, but they obviously vary in proportions and grain sizes. So the fine grain granites also tend to be less biotite rich in general. So the main coarse grain porphyritic granite is the most common rock type in the study area. It occurs as a voluminous granitic mass, which is marked by a series of joints with one set trending northwest-southeast and the other trending more northeast-southwest. This can be seen in Figure A. It's also the coarsest phase at the sea point contact and is characterized by these 2.5 to 10 centimeter K feldspar phenocrysts or megacrysts for the larger varieties, which are set in coarse matrix comprising in order of abundance quartz, non-megacrystic K feldspars, pleasure clays, biotite, cordierite, and muscovite. So garnet also occurs as an accessory phase in this granite. So K feldspar occurs in one of two varieties, macrocline, which is less common, and orthoclase, which is more common. So I included some outcrop photographs of the K feldspar grains, as can be seen in Figure D and E. So Figure E is a Carlsbad twinned euhedral K feldspar, and Figure D is a large subhedral percolitic feldspar with well-defined crystallographically aligned biotite grains aligned relative to the internal zonation of the grain. So some of the more common features in the main coarse grain granite include the biotite quartz clots, which are highlighted in the yellow circles in Figure A, but are shown in more detail in Figure B. And then you have enclaves, which are shown in Figure C here, an example of which is a granodioritic enclave. And you also have a common occurrence of this megacrystic magmatic structures in the form of megacrystic pipes, which are defined as like a mechanical concentration of more than 70% K feldspar. Okay, so this slide shows the other granite types at the contact. Figure A shows the appearance of the fine grained granite at the northern portion of the outcrop, whereas Figure B shows the appearance of the fine grained granite at the southern portion of the outcrop. Figure C and D are just some of the examples of the hybrid granites in the main contact zone, comprising the medium grain granite and fine grain granite and the associated subtypes. As you can see, the granites commonly have gradational contacts with minimal cross-cutting relations. So they also predominantly have a gradational contact with the country rock, as you'll see in the next slide. But overall, this gradational type contact diminishes as one heads further south away from the main contact zone and into the main S-type pluton, where the amount of spacing of granite sheeting gives way to more massive outcrops of granite. Okay, so this slide shows some of the geological features and contact relationships that have important implications related to the modes of emplacement. So figure A and B show the outcrop evidence of ductility of the country rock, where the country rock bodies are elongated with a wavy appearance. So some of the granitic materials help to highlight the ductility of the country rock because they occur as pinch and swirl structures or budines, which are defined as regularly shaped and spaced fragments, which are formed by the stretching of competent layers and are usually developed within a matrix that deforms plastically. Figure C is an example of one of several country rock xenoliths, which are found in the outcrop. This particular example is a rotated xenolith that still has a primary bedding structure preserved. So it is set or embedded in a matrix in a rock, in a mixed rock with characteristics of both granite and country rock. So as you can see, the two rocks are quite mixed. There's no better term for it. Where the country rock is more phosphathic, and in turn the granites tends to be more biotite rich, forming this hybrid rock. Figure D is an example of a unique feature which is found in the main contact zone, whereby several K-feldspar megacrysts from the granite are found embedded in the country rock. This is, as you can see here, this is an example of that. So these megacrysts show variable degrees of entrapment in the country rock, and they range from totally isolated to associated with and surrounded by trails of orthophosphatic granitic material. Okay, I will start detailing the history of the outcrop. Apologies for the lack of pictures in the next few slides. A lot of the historical pictures I wanted to use required a lot of permissions, so I just decided to leave them out. Okay, for those interested in the overall history of the Cape geology and the various scientists and explorers that have given accounts on it, particularly at the Table Mountain, I suggest that you read the highlighted paper by Shared Master. It provides quite a detailed summary, and yeah, it's well written. So if you're interested in the detailed history, I suggest that you read that paper. For today, I will just only highlight some of the more famous visits, like Basil Hall's visits to the Cape, which also happens to be the source of some confusion, as people have often given wrong accounts of his visit with respect to Darwin's visit. Okay, so Captain Basil Hall was the son of the renowned geologist James Hall. And he described the contact between the Cape granite and the Malmesbury Greywacke at the foot of Table Mountain in the Platteklip Gorge, in July 1812. So he sent out a letter directed to John Playfair, who was another prominent geologist at the time. And he also sent it to his father. So both of them are from the University of Edinburgh in Scotland. And in the letter, he spoke of observing outcrops of granite veins having intruded into sedimentary rocks. So John Playfair published these observations in 1813 as a crucial example of the intrusive origin of granite. This was the first published example of intrusive granite outside of Scotland at the time. So in other previously published accounts of the history of the Sea Point contact, the impression was that Darwin, which I'll describe in his visit in a bit more detail in the next slide. The impression was that Darwin had described the same outcrops as Basil Hall, Furthermore, it was stated that Darwin visited the granite outcrop at Sea Point because his attention had been drawn to it by Basil Hall's observations and the published paper by Playfair, and that he deliberately visited the outcrop to help sort out the controversy between the Platonists and the Neptunists, which was a debate which was raging at the time of his visit. So this account's, however, are not true, as Darwin didn't visit this site because of those reasons that I mentioned. It was, in fact, Clark Abel who was first to describe the granite country rock contact at Sea Point in 1818. I'll give a bit more detail about his observations at the end of the next slide. At the end of the next slide. Okay, so the Sea Point contact received more attention following the visit by Charles Darwin. So being the founder of the evolutionary theory, Darwin today is mostly associated with terms like natural selection and evolution. However, his first scientific achievements and publications, they dealt with geology, in fact. So he visited the outcrop in 1836 on the last leg of his famous voyage on the HMS Beagle. That's a ship under the under Captain Robert Fitzroy, who was the captain of the ship. So although not extensive, Darwin had some experience with geology before his voyage on the Beagle. So as a medicine student in Edinburgh University from 1825 to 1827, Darwin actually attended formal lectures by Professor Robert Jameson, who was one of the main advocates of the Neptunist view at the time. However, it is well known that Darwin actually disliked the teachings of Robert Jameson and never actively joined another lecture about geology for his remaining duration as a student at the university. However, he did have other experiences with geology after his university days, where he attended several field excursions to Wales with Adam Sedgwick, who was a professor at Cambridge University and was regarded as a leading field geologist at that time. So Darwin arrived at the Cape on the 31st of May, 1836. He first visited the Pearl Mountain on the 4th of June, 1836. And he then visited and described the Sea Point contact, which he actually called the Green Point contact at that time, from the 8th to the 15th of June, 1836. So while Darwin was not involved in any major way, his visit came at a time when there were conflicting schools of thought in geology, which revolved around the Newtonian Platonism and Avernian Neptunism controversy in the early 19th century. So Neptunists like Robert Jameson, who was a former lecturer of Darwin, inferred that most rocks, including granite and basalt, were actually precipitated from a primordial ocean, an idea first proposed by Abraham Werner. Platonists like John Playfair and Basil Hall's father, James Hall, instead invoked a magmatic origin for igneous rocks by stating that they originally formed deep within the earth. So the Platonist view was first proposed by the legendary geologist James Hutton. So Clark Abel was also interestingly a Neptunist. And he actually gave very good and accurate sketches of the contact. But at the time of his visit, he agreed that the granite had an intrusive origin. However, he then regarded the overlying sandstones of the Table Mountain as having been precipitated from the ocean in a manner advocated by the Neptunists. So in essence, he agreed with both theories when he described the contact. Darwin's account and later interpretation of the outcrop was built on 8 years of reflective thought and writing after his voyage on the Beagle, when he had an extensive time to read his library and correspond with other eminent authorities. His observations were published in his book titled Geological Observations on the Volcanic Islands in 1844. So his observations of the outcrop were as follows. He saw the granites as a source of heat that affected the rocks it had intruded and changed the appearance from sedimentary rocks to metamorphic rocks. He described the effects of contact metamorphism, which was not well known at that time, by observing the coarsening of mica towards the contact. And he mentioned the occurrence of cordierite in the country rock. He noted that the country rock xenoliths in the granite preserved the original cleavage and were intruded along the schistosity plains by thin fingers of granite, but argued that the xenoliths were part of a slate overmass, which was worn down by erosion to reveal detached floating fragments in the granite, and he did not necessarily view them as fragments carried by the intrusive magma. And lastly, he noted that for granite to be intruded at depth, it would require long periods of time. So the significance of Darwin's visits, of Darwin's observations are as follows. Darwin's observations at Sea Point supported the Plutonist viewpoint that the granite was indeed a product of magma crystallization and not precipitated from a primordial ocean. So he recognized gaps in the stratigraphic record, which many geologists at the time believed was simply continuous. And as I mentioned earlier on, he recognized the long periods of time required to expose rocks by erosion. So the Sea Point contact has been a site of geological significance even 2 centuries after Darwin's visit. So the contact has allowed for the study of the following geological concept throughout the years. The first is emplacement mechanisms, the role of pre-existing deformational features in the country rock in controlling granite emplacement. The petrogenesis, relationships, and relative timing of emplacement of the granite, of the different types of granite, and the role in constructing a granitic Pluton, as well as the origin of K feldspars embedded in fine-grained metasedimentary host rock. So my thesis provides a more recent account of all these topics, but my former supervisors and I also have submitted manuscripts for review and possible publications related to a more detailed account of the embedding of the magmatic crystals at the outcrop and the other relating to granite emplacement mechanisms. There's also a paper regarding the Sea Point contact and its geological significance, which my presentation draws inspiration from. This will be published in September as part of Dr. René Clary's special volume of Global Geo-Heritage Localities for the Geological Society of London. Okay, so these are some of the possible topics that could still be investigated at the Sea Point contact. The first is the effects and extent of thermal contact metamorphism on a low-grade sedimentary country rock due to intrusions, with particular implications on the prograde release of fluids and late magmatic partial rehydration of all rocks from the granite-derived fluids. The second one is the extent to which the host rock, in the case of the Sea Point, the Malmesbury group, how it's been incorporated or assimilated into granite magma, and how this process can potentially influence the composition of granitic magmas at the contact, as you've seen in the pictures from my earlier slides. Yeah, so that's the end of my presentation. These are some of the references that you can use if you want to read more about the Cape geology as well as the seaborne contact. My thesis is freely available to read. If you can just type my name and the word seaborne contact, you'll find it. It's quite a detailed study, but it covers most of the concept and I've described today. So yeah, thanks for listening once again. Thank you.
Musa, thank you so much. That was incredibly interesting. Do we have any questions or comments? Well, it seems that you were so detailed that nobody has any questions.
Yeah, thank you.
Thank you again.
All right. Just want to stop sharing. Yeah.
Sure. There is a comment from Zandri who just went, well done, guys. And I agree with her. Both these talks were very, very interesting and so professionally done. We will put them onto YouTube. I will share the links as soon as we've done a bit of editing and separated them. Our next talks by our mentees will be on the 25th of July at 1 o'clock. And that will be Jesse Kaniere and Quentin Bapele. So again, keep your eye out on the calendar for the links. And hopefully there'll be less chaos than today's talks. But you guys have done incredibly well. Thank you so much.
Thanks, Noni.
Okay. Last chance for any questions? No? Have a fabulous day. Kate, if you're there, you can close the meeting. Or people can just leave.